So we want to continue with graphing quadratic equations, but now we're going to do some adding and subtracting from the basic function. We're going to use a table of values to graph each of these equations. I want you also to find the domain, the range, the vertex, and the axis of symmetry for each of the graphs. Let's make a table of values here to start. And so that we're both using the same numbers, why don't we try x equals -2, -1, 0, 1, and 2. Pause your video, find the values of y for this equation. So these are the values you should have found for y. If you have any issues with that, make sure you ask when we meet in Zoom class. We have a point at -2, 0, -1, -3, 0, -4, 1, -3, and 2, 0. Again, we can see our parabola here. We said that the domain for every quadratic equation is the set of all real numbers, from -infinity to +infinity. But what about the range? This parabola opens up. That means the vertex is its lowest point. The vertex is here at 0, -4. That -4 is the lowest point on the graph. It opens up to +infinity. And remember, the axis of symmetry is the vertical line through the vertex where x equals 0. Let's make a table of values for the second one here. Be careful because we have that negative sign. And let's use these numbers again. Pause your video, find the values of y. These are the values you should have found for y, but let's just talk about x equals -2 and just make sure you know what you're doing here in case you had some difficulty. If x is -2, we have y equals the negative of x. X is -2 squared plus 3. Again, remember that negative sign is sitting outside of x. X is equaling -2. So we've changed x to -2. So this is the negative of 4 plus 3, which equals -1. If you need some practice with that substitution, you may need to go back to the lessons in weeks 1 and 2 and find that practice there. So let's plot these ordered pairs. -2, -1, -1, 2, 0, 3, 1, 2, and 2, -1. So again, our quadratic equation gives us a shape that is a parabola. This one opens down. And again, like all quadratic equations, it has a domain of all real numbers. Because it's opening down, the vertex here at 0, 3 is the highest point. The highest point for y is that 3. It's going down to -infinity and then up till 3, closed bracket. The axis of symmetry is that vertical line through the vertex where x equals 0. You may want to pause your video, go back, and try graphing these two equations again. Let's look at the example in question 3. Again, I've created our table of values and used these same numbers for x. Find the values of y for these values of x. You should notice that these values of y look a little strange. If we go back to the earlier questions, we had a sense of symmetry going on. There was a 0 and a 0. And then a -3 and a -3. And finally, our vertex here in the middle. That was true with these as well. Our vertex in the middle, a 2 and a 2, a -1 and a -1. That's not happening here. That means these numbers aren't working for us very well. Maybe we should try to find 3. Let's see what happens when we substitute in 3. We have -9. 3 times 4 is 12 minus 3. It gives us a 0. Now we're getting that symmetry again. What about 4? -16 plus 16 minus 3. This is -3. This is much better. So we can actually ignore these values here. But now I have that symmetry we were looking for. Let's graph this equation. So we have a point at 0, -3, 1, 0, 2, 1, 3, 0, 4, -3. A parabola. Now we could have graphed -2, -15. That would have been down here somewhere. It's not necessary. The domain is again the set of all real numbers. Infinitely left, infinitely right. The vertex is the highest point. It's that piece right here in the middle. 2, 1. So the range then, continuing down to -infinity, remember we always start at our lowest values, up to our highest y value in the range is at the vertex, a point on the graph. The axis of symmetry is that line through the vertex. What is it this time? X equals 2, not 0. Why don't you pause the video and see if you can come up with numbers that work for question 4. Create your own table of values, draw the graph, and then turn the video back on. Your graph should look like this. It may have taken you a few tries to find the right ordered pairs, the right values of X to use. Now, why don't you fill in the domain, the range, the vertex, and the axis of symmetry? So for all quadratic equations, the domain is the set of all real numbers. The vertex is that point, the lowest point of a parabola that opens up. And we see that y is the lowest point then. So our range starts at 0 and goes up to positive infinity. The axis of symmetry is that vertical line through the vertex where x equals -2. Make sure you spend a lot of time practicing graphing quadratic equations using a table of values, finding the vertex, and all of the other information that goes with one of these graphs.